Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alvisha bin Muhammad Karul Alwi, and this is my group member Muhammad Salman bin Alzian, Aidil Udan Bistan, and Aquinas Masalinus Anak Majah. And today we are going to present a video presentation, Chemical Thermodynamics, CMT 252. And the question one is, temperature can determine the rate at which certain physical and chemical change proceed, whether some change can occur at all. So discuss at least three temperature measuring devices, which is we have choose three liquid in glass thermometer, thermocouples, and resistant temperature detector RTD. This is the example of liquid in glass thermometer. This is the example of thermocouples, and this is the resistant temperature detector.
Operational principle for liquid gas thermometer. The idea behind liquid in glass thermometer is that materials expand as they heat up. When heated or cooled, a liquid in a glass tube known as a capillary expands and shrinks. The temperature that causes each corresponding thermal expansion can then be determined using a calibrated scale. The volume of liquid in a liquid in glass thermometer affects how sensitive it is to temperature measurements. More liquid will expand and rise in the glass tube as there is more of it. Liquid thermometers are designed with a reservoir to hold more liquid for this reason. However, too much liquid would slow down the thermometer's response to temperature change since it would take longer for the liquid to heat up and adjust to the display outside temperature. The liquid in glass thermometer advantages: no power source required, repeatable calibration does not drift, easy to use and cheap. And disadvantages: limited to applications where manual reading is acceptable. Household thermometer have a limited usable temperature range and cannot be digitized or automated. The costs are cheap and easily obtained through apparatus selling stores for lab equipment, and the price is 70 ringgit to 140 ringgit. Range of capability. Liquid in glass thermometers use a length scale to measure the thermal expansion for a liquid that is contained in a solid object. One type of liquid thermometer is the mercury thermometer. Additionally, alcohol is employed with this kind of instrument. Depending on the liquid, the temperature range is between 80 and 330 Celsius. It is mostly used to measure body temperature in household and hospitals. To measure the atmosphere's suitability for flying in aircraft applications. And application in oceanography and meteorology use it. Models for predicting the weather can be measured.
So we have moved on to another device which is selected for our group, which is a thermocouple. Here are the operational principles of it. So a thermocouple is that it is a sensor that measures temperature, and it is made out of two different metals that are attached to one of each end. Voltage will be produced that is related to the temperature when the junction of two metals is heated or either cooled. For thermocouples are also voltage instruments that change in voltage to indicate the measurement of the temperature. Thermocouples output voltage increases with the temperature, though not as always as linearly. Thermocouples are, I say, here are the advantages of having a thermocouple. For the advantages, the display for measurement is easy to read. It is also durable on certain workplaces. It can also measure temperature variations over a distance of less than 1 centimeter. and it also gives a rapid response. For the disadvantages, it has an ancillary equipment which is expensive. It is also very hard to calibrate, measures only temperature difference, and is also a self-powered active device. So it does not require current or voltage sources. Now for the cost, it ranges from 50 ringgit to 200 ringgit. And thermocouples are typically selected because of their low cost, high temperature limits, wide temperature ranges, and also its durable nature. For the range of applicability, a thermocouple can at least measure from negative 457 to 2300 Fahrenheit, which is equivalent to negative 270 degrees Celsius to 1260 degrees Celsius. For thermocouples, they are reliable as they are self-powered and flexible enough to use to measure temperatures, for example, of car engines to laboratory experiments relating with heat. You can also find them in home appliances, industrial operations, electric power generation, furnace monitoring, food beverage, and be it industrial use.
So it is a resistance temperature detector RTD. A sensor called an RTD varies in resistance as a function of temperature. As the sensor temperature rises, the resistor rise as well. The link between resistance and temperature is widely known and repeatable over time. A passive device is an RTD. It doesn't generate an output by itself. By running a modest electrical current through the sensor to produce a voltage, external electronic devices can measure the sensor resistance. Typically, measuring current are not more than 1 milliampere and no more than 5 milliampere without the risk of self-heating. Next, pick how accurate you need your measurement to be. Best resistance tolerance and temperature coefficient of resistance tolerance together determine accuracy. A wider tolerance zone or less accuracy will apply to any temperature above or below this one. 0 degrees Celsius is the usual calibration temperature. So here are the advantages and disadvantages for RTD. So for the advantage, compared to a thermocouple, it is more sensitive and more stable when readings are taken. When taking a temperature, reading it measure it is more accurately. Readings are more linear. So for the disadvantages, when maintaining and purchasing the RTD, it is expensive. It requires an electric current source. Its size is small compared to most temperature reading devices. It is a self-heating and the RTD has more best resistance. So for it costs around 70 ringgit to 500 ringgit. For more accurate, RTDs, the prices are more expensive as the device is more sensitive when taking temperatures. So the range of applicability with temperature range of between 250 and 1000 degrees Celsius, the RTD can often be used over a wider temperature range than a thermostat. For monitoring the resistance change that take place, a constant voltage bridge circuit similar to that used with strain gauge is typically utilized.
So for the last one, we have the question three, which device would you recommend for use in the following case? Monitoring the variation of temperature of a car engine block at several locations. We choose the resistant temperature detector (RTD). monitoring the temperature in the furnace of power plant. The resistant temperature detector RTD or thermocouples were both are electrical sensors that produce a MV signal in response to temperature changes. That's all from us. Thank you very much for listening.